Hey guys, welcome back to another fresh episode on wireless technology. So in today's video, let's see the different types of standards which are seen in the IEEE 802.11. So those are basically called as the 802.11x. So X stands for different types of versions, like you have 802.11a, 802.11m, 802.11r, like, and different kinds of standards are there. So in today's video, I have considered 8 different standards which are most widely used in the 802.11 standards. So let's begin. So we start with the very first one as the 802.11ad. So it's also called as the Y-gig technology. So it enables, or what is the speciality of this kind of standard is that faster session transfer is maintained in this kind of standard, and so the transmissions usually happen in the 2.4 or either 5 or either 60 gigahertz frequency bands. Now the data transfer which is done in the 60 gigahertz bands are mainly done with the help of physical layer, and it enables personal basic service set, and then it also provides the directional antennas, and there is something called as the beam forming. So that beam forming is mainly done for faster data transfers if it is required. Next we move on to the standard called as the 802.11ae. So it mainly focuses on prioritization of the frame mechanism. Now in 802.11 we have seen many different kinds of packet structures, like we have the DSSS, FHSS and IR packet structure. So in that we had different frame formats, different fields were there. So the manner or the fashion in which different frames are processed are basically taken care with this kind of standard. So basically a protocol, that is a management frame prioritization policy, communicates the way in which different frames has to be sent. Next we have the 802.11ac. So it aims at data delivery at 433 Mbps, and it is done with the help of a spatial stream. So spatial stream, just consider it as a technique of MIMO, that is multiple input multiple output. So it's a technology in which you just have different kinds of inputs and you have different kinds of outputs. So it's a kind of, you can say it's a multiplexer or a duplexer, where you have n number of inputs coming and then you will be assigning n number of different outputs to different nodes. So if this is a technique one, so you have another data speed, that is you can achieve up to 1.3 gigabytes per second in a 3-stream design technique. So it's some kind of different technology where you have a 3-stream designing, and with that speed you can have this data transfer achievable. Next it operates within the 5 gigahertz frequency range. So this is a standard frequency range on which it operates. If you want to extend it even more, it can operate at 80 to 160 megahertz. Now if you want even more data transfer speeds, like more than this or more than this, you can go for beam forming, which is taken from the 802.11ad. Next we have the 802.11af. So it operates in the TV white spaces, something called as the TVWS. So it aims at unused frequency in the TV spectrum. So in the TV spectrum, for example, if there is a large geographical area, if a large area is there, and if TV broadcasting is to be done, and if there are multiple TV spectrums allocated to that particular area, and if at some places some frequencies remain unused, so this majorly takes care of that. That is the 802.11af. Next we have the 802.11ah. It provides the subscribers to use the subcarrier frequency, which is below the 1 gigahertz in the ISM, that is the industrial, scientific and the medical band. So basically the frequencies which are there, or the 1 gigahertz, are not accessible, or it is being unlicensed. So if you want to use this below 1 gigahertz in the ISM band, you can make use of this standard, that is 802.11ah. Next we have the 802.11ai. So it offers something called as the fast initial link setup, which is called as the FILS, which provides faster data speeds to the clients between the access points in order to do the data transfer, and it also helps those devices which are participating in the data transfer to establish something it's called as a protected connection, and it should be less than, or it is provided with less than 100 milliseconds. Next we have something called as the 802.11nc. So it's an advanced version of the 802.11n. So this is another substandard. So from here it got evolved from 802.11nc, and it basically assigns an operating group with the task of managing the standard. So it nothing greatly cares about this particular standard. Just it maintains a group of tasks, that is you can consider as the IETF group of task force, which just maintains this band so that it is used properly. Next we have something called as the 802.11 AJ. So it modifies the physical layer and the MAC layer, which we saw in WLAN, of the 802.11 AD, that is this standard, and functions in something called as the Chinese millimeter wave. So it's called as the CMMW, and this basically operates in the frequency bands of 59 to 64 megahertz. So if this frequency band is seen in the IEEE 802.11, so it falls under this Chinese millimeter wave, which basically operates in 802.11 HA. So well, that was all regarding the latest developments in the IEEE 802.11 standard. So hope you guys enjoyed this video, found out educative about this video. Please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.